Hello everyone, welcome back to our channel. Once again, I am here with the third and last part of fifth chapter complex numbers and quadratic equations of class 11th. So we will start this video with the explanation of modulus and conjugate properties followed by Argand plane. Then we will be having polar representation of a complex number. After that, we will discuss measurement of argument, then examples, and at last, like always, we will be having a pop quiz. Let's have a recap what all topics I have covered in my last two videos of this chapter. So there we are having number system, introduction of iota, integral powers of iota, introduction of complex numbers, conjugate of complex numbers, and operation on complex numbers. In case if you have missed these videos, please refer the link from the description box. So let's get started with the modulus and conjugate properties. So conjugate I have explained in my last video. What is modulus? Modulus means we consider non-negative value of any number without regard to its sign. So if we have to find out modulus of any two complex numbers like this, if we are having two complex numbers z1 and z2 and we are multiplying these two numbers and then we are finding out modulus, means mod of z1 into z2 will always be equals to mod of z1 into mod of z2, means modulus is distributing to each complex number with respect to product here. Just like this, if we are finding out modulus of z1 upon z2, it will be equal to mod of z1 divided by mod of z2, and mod of z2 can't be 0 here because z2 is lying here in the denominator. Now let's discuss properties of conjugate. So if you are finding out conjugate of z1 into z2, it will be equal to conjugate of z1 into conjugate of z2. And if we are finding out conjugate of z1 plus z2, it will be equals to indivisible conjugate of z1 plus indivisible conjugate of z2. Then if we are finding out conjugate of the subtraction of two complex numbers, it will be equal to indivisible conjugate of subtraction, means conjugate of z1 minus z2 is equals to conjugate of z1 minus conjugate of z2. And then conjugate of z1 upon z2 will be equal to conjugate of z1 upon conjugate of z2, provided z2 can't be equal to 0 because again z2 is lying here in the denominator, and you know well in the denominator we can't be having 0 there. Now let's find out what is Argand plane. Argand plane is just like coordinate plane. Coordinate plane we are having where we are representing real numbers, just like that. Argand plane we are having where we represent our complex numbers. So a complex number a plus ib corresponds to the ordered pair ab, just like coordinates, can be represented geometrically as a unique point PAB in the XY plane. Yes. So let's have some examples. If we are having minus 4 plus 3i, 3 plus 2i, minus 2 minus 3i, then we can write these complex numbers in the form of ordered pair. This can be written as minus 4, 3, 3 plus 2i can be written as 3, 2. And minus 2 minus 3i can be written as minus 2 minus 3. Now I'm going to show you Argand plane. Here in Argand plane, x-axis is known as real axis and y-axis is known as imaginary axis, because here we will plot complex numbers which are involving real part and imaginary part. So now you can see here a complex number a plus ib, how we can denote it here, just by covering a units towards real axis because a is representing here real part, and b units towards imaginary axis because b is representing here imaginary part. Then by drawing perpendicular from a towards the upward direction parallel to imaginary axis, then perpendicular from the point B towards the real axis direction parallel to the real axis, and where these two perpendiculars are intersecting, this is giving us the point AB, which is representing our complex number A plus IB. Just like this, we can represent minus 4 plus 3i, because this is denoting here ordered pair minus 4, 3. So just we will plot the point minus 4, 3. Here we are having our complex number minus 4 plus 3i. Just like this, 3 plus 2i is representing 3, 2 ordered pair. So 3 and 2. Here we are having point 3 plus 2i. Then minus 2 minus 3i, it is representing here minus 2 minus 3 ordered pair. So it will be minus 2 and minus 3. Here you can see point we are having here, minus 2 minus 3i. So this is the way you can represent any kind of complex number in the Argand plane. Now I would like to tell you, if you are having numbers like this, minus 5, in terms of complex number system, this is purely real complex number, because here imaginary part is 0. So we will write it in terms of ordered pair, just like minus 5, 0. And next number is I. You can see its real part is 0. So this is purely imaginary number. Its real part is 0. So we can write it in terms of ordered pair like 0, 1. So minus 5, 0 will be located here on the x-axis in negative direction. Here at the point minus 5, this is the point minus 5, 0, and 0, 1 we are having here at the imaginary axis. This point will always lie on the imaginary axis only, 0, 1. So this point is representing the complex number I. This point is representing the complex number I. So what is the Argand plane? We got to know that plane having a complex number assigned to each of its point is known as a complex or Argand plane, right? So this was all about Argand plane. Now, representation of a complex number z plus xy and its conjugate x minus iy in the Argand plane. So I have explained you conjugate in my last video. So what is the conjugate of x plus iy? It will be x minus iy. What we do just to find out the conjugate, just we need to replace the sign involving it in between real part and imaginary part with the opposite sign. You can see here we are having negative, because here we were having positive sign. So just reverse the sign, you will always get conjugate of any given complex number. Now z is equals to x plus iy can be written in the form of ordered pair as xy, and x minus iy can be written in the form of ordered pair like x minus y. Let this is indicating the point A, and ordered pair x minus y can be represented by point B. Then I can show you a general plot of general complex number x plus iy. How we can plot? So here you can see I have shown you the point A somewhere here, xy, because it is xy means x plus iy. Here we are having at the point A, right? Then it's conjugate x minus iy, that is x minus y. Here we are having at the point B, and you can see here the point B, x minus y, that is conjugate of xy, will lie always exactly at the same distance in the reverse direction where the point xy is lying, at the same distance with respect to x-axis or real axis, right? Means these two distances are same for the conjugate of a given complex number. So geometrically, B of x minus y is the mirror image of A of xy. Here, always if you are having any complex number, its conjugate will represent its mirror image there. Here, B of x minus y is representing mirror image of A of xy, because always at the same distance, we get our image from the mirror. This you have studied in science, right? Our image through the mirror always just framed out exactly at the same distance behind the mirror at which we are present there. So this is the mirror image of XY point. Now let's find out what is polar representation of a complex number. So let point P is representing the complex number Z is equals to x plus iy. So I have explained you in my last slide that how we can represent a complex number x plus iy in the form of ordered pair, and how we can plot in the Argand plane. So this is the representation of a complex number. Now for polar coordinate system, if we are having this distance OP is equals to r, and the angle between real axis and the line segment OP is theta, then in terms of r and theta, we can write this complex number Z is equals to x plus iy. This is known as the polar coordinate system, where we represent any complex number in the terms of r and theta. And what is r? R is the distance of the line segment OP, or length of the line segment OP, and theta is the angle between x-axis and the line segment OP in anti-clockwise direction. So in polar coordinate system, we will be having polar coordinates of this point P, R and theta, and origin will be known as pole here, and positive x-axis will be known as initial line for polar coordinate system, right? So now you can see here I have shown you complex number, a general complex number Z is equals to x plus iy, which is indicating here point P. Now it is having coordinates r theta in terms of polar coordinates, right? Now in trigonometry, you have studied that sine theta is equals to perpendicular upon hypotenuse and cos theta is equals to base upon hypotenuse. Then if we have to find out the value of P, then P will be equal to h into sine theta and B will be equal to h into cos theta. So here, you know, well, this is x and this is y. So in triangle OPX, sine theta, if we are having this angle theta, then sine theta will be perpendicular upon hypotenuse. So OP will be equals to r into sine theta, because hypotenuse is r here. So in this formula, P is OP and H is R. So P will be R into sine theta. Just with the help of cross multiplication, we can have this length OP is equals to R sine theta, right? Just like this, cos theta, again in this triangle, cos theta will be equals to base upon hypotenuse. So base we are having OX. So OX upon R. So OX will be equal to R into cos theta by cross multiplication. So OX we are having R cos theta and OX is equals to PY. That's why we can write this length as R cos theta. So as you know well, when we are representing point P with the complex number Z is equals to x plus iy, then this distance OX is x and PX is y. So x is equals to r cos theta we are having now in terms of polar coordinates, and y is equals to r sine theta, right, in terms of polar coordinates. So we can replace x and y with these values in Z is equals to x plus iy. Then after replacing, we are having value of any complex number in terms of polar coordinates, that is r into cos theta plus I into sine theta. This is the polar representation of a complex number, where r is equals to a square root of x square plus y square, which is equals to modulus of z. How we got this measurement? Actually, in triangle OPX, with the help of Pythagoras theorem, you know, this is x and this is y, and here as it is a right angled triangle, so this is perpendicular, this is base and this is hypotenuse. So Square of hypotenuse, that is r square, will be equal to x square plus y square. So r will be equal to square root of x square plus y square, and this is equals to modulus of z. It means value of r is equals to modulus of z. Why we are writing it modulus of z? Because this is a length, this is a distance, and distance can't be negative. That's why we are putting here modulus, because always it will be positive only. So mod z is known as modulus of z, and angle theta is known as argument or amplitude of z in polar coordinate system. And we can measure angle theta with the help of this relation. Tan theta is equals to y by x is equals to modulus of imaginary part of z upon real part of z. Y is the imaginary part and x is the real part. And how we got this relation? You can see here we are having these two terms. So just by dividing this second term by first term, so r sin theta upon r cos theta will give us tan theta is equals to y upon x. So from these two terms, from these two relations, we are developing this relation. So this is the formula which you can use in order to find out the value of argument or amplitude. Now we will discuss how to measure argument. So if we are having angle theta lying between 0 and pi by 2. So first you should know that here real axis or x-axis is representing 0 angle. Then in anti-clockwise direction, gradually we increase the angle. And y-axis, you know well, this angle is 90 degrees. So y-axis is representing the angle pi by 2. So this is representing basically line pi by 2. And this straight line is the linear angle, means this is representing here angle pi. When we are measuring angle in anti-clockwise direction, right? So if theta is lying between 0 and pi by 2, so it will lie always in first quadrant. Our complex number will lie in first quadrant. Now if theta is lying between pi by 2 and pi, so pi by 2 and pi, we are having this second quadrant. So somewhere in second quadrant our complex number will lie. And we will measure its argument or amplitude like this in anti-clockwise direction. So this is giving us angle theta. Now, if we are having theta which is lying between minus pi by 2 to minus pi, right? Here we are having negative direction. So you should know that this line y-axis or imaginary axis is representing angle pi by 2 in upward direction. Then exactly in reverse direction, it is representing angle minus pi by 2 when we are measuring angle in clockwise direction. And when we are measuring angle in clockwise direction, then this straight line is representing here angle minus pi. So if theta is lying between minus pi by 2 and minus pi, means it is lying somewhere in third quadrant. In third quadrant, but we are measuring it in clockwise direction. So here we are having angle theta from this direction, means in clockwise direction from positive x-axis, and our complex number will lie in third quadrant. Now, if theta is lying between 0 and minus pi by 2, so 0, you know, x-axis is showing 0 angle, and minus pi by 2, this line is indicating. So 0 and minus pi by 2 means our complex number will lie in fourth quadrant, and theta we will measure in clockwise direction, and somewhere in fourth quadrant we will be having angle theta just like this. So this is the measurement of argument in different situations. Now let's have some examples. So first question, find the modulus and argument of complex number z is equals to minus 2 plus 2i under root 3. So z is equals to -2 plus 2i root 3. Here we are having real part -2 and imaginary part 2 under root 3. Now, as you know well, modulus of z we can calculate just by finding out square root of x square plus y square, where x is real part and y is imaginary part. So we need to do -2 whole square plus 2 root 3 whole square. It will give us 16. Square root of 16 means 4. As we are taking here only positive values, modulus of z we are finding out. That's why we will consider only positive number here, means +4. So this is the modulus of this given complex number. Now let alpha be the angle. Then I have explained you how we can calculate alpha. So tan alpha is equals to modulus of imaginary part of z upon real part of z. So imaginary part you are having 2 root 3 and real part you are having -2. So just by doing this calculation, we are having modulus of -√3, and modulus means we need to take only positive value, so it will be √3. Now we need to check at which angle value of tan is equals to √3. So it is at the angle pi by 3. So value of alpha we are having pi by 3. After this, we need to check what kind of real and imaginary parts we are having. As real part of z is less than 0 and imaginary part of z is greater than 0, it means our complex number is lying in second quadrant. But here what we calculated, our argument is indicating that this angle is lying in first quadrant, but our complex number is lying in second quadrant. So we need to find out argument of z just by subtracting this angle alpha from pi. So pi minus alpha will give us argument of z. So pi minus pi by 3, that is 2 pi by 3 is the argument of this complex number. So this is a solution of this question. Let's have another example. Represent the complex number z is equals to 1 plus I root 3 in polar form. So this is in general, x is 1 and y is √3 here. And as you know, we are having polar coordinates. X is equals to r cos theta and y is equals to r sin theta. So just by replacing x and y by 1 and √3, we are having these relations here. Now, just by squaring these two relations and then adding, we are having r square into cos square theta plus sin square theta is equals to 4. And cos square theta plus sin square theta from trigonometry we are having is this is equals to 1. So r square is equals to 4, means r is equals to square root of 4. So its value we are having 2 now. So we got the value of r. Now we have to find out value of theta. As we are having these relations, so by putting value of r here in these two relations, we are having cos theta is equals to 1 by 2 and sin theta is equals to √3 by 2. Then theta is implying here it is pi by 3, because now we need to check at which angle value of cos is 1 by 2 as well as value of sin is √3 by 2. Because these both values are positive, so we are considering here theta as lying in first quadrant. So value of theta will be pi by 3 here. And then our complex number will be in terms of polar form, like 2 into cos pi by 3 plus I into sin pi by 3. So this is the polar representation of the given complex number. Here I can show you with the help of figure that you can see our complex number z is equals to 1 plus I root 3 in terms of ordered pair can be written as 1 root 3. So here this point P I have shown you 1 root 3. This is our complex number here. And this distance R which we have calculated 2 is indicating this length. This is 2 we are having, and our angle theta pi by 3 we are having this, means the angle between positive x-axis and the line which is joining the point indicating our complex number to the origin. This is the angle or amplitude of our complex number, which is pi by 3. So this is a little representation of given complex number in Argand plane. Now get ready for the pop quiz. So our first question is, find the conjugate of I minus I square whole cube. Yes, conjugate of this question you have to find out. So what you need to do first? First, you have to simplify this term. After that, you can write its conjugate easily. So I'm going to tell you its answer. Its answer is minus 2i, means after reducing this term in linear form, you will be having minus 2 plus 2i. Then its conjugate is minus 2i. Let's have another question. Find the modulus and argument of minus root 3 minus I. Yes, modulus and argument. So its answer is 2 is the modulus and minus 5 pi by 6 is the argument, right? So modulus formula I have explained you. Mod of z can be written as square root of x square plus y square, and amplitude you can find out just by dividing real imaginary part by real part. Then polar form of 1 minus I you have to write. Yes, you have to do it. And its answer is square root of 2 cos pi by 4 minus I sin pi by 4. Then our next question is, write I to the power 25 to the whole power 3 in polar form. Yes. So first you need to simplify this. Then you can write easily it in terms of polar form. So answer is cos pi by 2 minus I sin pi by 2. So that's all for this video. Thanks for connecting with me. See you soon in the next video. Till then, take care. Bye-bye.